Okay, hi. So we are finally in week 8 now. We've seen a lot of C programming already and some C concepts as well. There are some more concepts associated with functions that we did not discuss in week 7. So this lecture is about those concepts. So what we've really seen till now is that whether part of a library or defined by us, functions can be used to perform a number of tasks, right? So we can use them for printing values using the printf function, for example. We have used functions for mathematical functions like square root, right, through the that sqrt function from the math library, and we also created a function called trim over strings, right, which simply removed the leading and trailing spaces from a string. So we have used a number of functions till now, right? However, there are still some use cases for which we have not really found a solution, right? So, for instance, we know that functions can only return a single value, right? So that the return statement cannot actually return something like return a comma b, right? So you can only return a or b, right? Not both. You can always, of course, return an array, but that is not really the same, right? I mean, we are talking about values as in one variable, so you can basically only return the value to one particular variable. Now at times you may actually need these things, right? So you might actually want a particular function to be able to return more than one values, right? There is a kind of trick that many programming languages provide in order to get more than one outputs from a function. This trick is to actually pass the parameters by something known as reference and not really by value. So what do we really mean by passing parameters by value? So in C, actually, whenever you make a function call, right? So whenever you say something like f and then you pass something like a comma b, the parameters are passed by value. Okay, so this means that the actual parameters travel to the called function, right? Travel as in the past parameters, whatever are their current value. So if it's a constant, then of course the constant is the actual value, but if it's a variable, the current value of the variable basically goes to the function, the called function, right? These values are then copied into some new memory locations. So no, the formal parameters that we saw, the formal parameters get these new get these values copied to them into new memory locations. So for example, if we have two functions f and g, and f is calling g, then and also g is expecting two parameters, a and b, both integers. What really happens is that in the beginning you have some space in memory allocated for the execution of f, the local variable a, right? So this is a local variable a. It gets some space in this allocated block. Okay, then at some point of time, you'll start changing the values of a, the value that is just there, right, just before the function call. It is that value that is the one that will be passed to this function g, right? So essentially, when you make a call to g, some space is set aside in the memory for execution of g, something like this, and then two variables in g are created here like a and b, and what happens really is that the value of a is being copied to the a variable here, and the value 5, right, which is a constant, gets copied to b here. So this is so essentially what is happening is that these a and b are being initialized by the values 10 and 5. So these memory locations, right, the new memory locations where the new a and the b variable was created, these memory locations are active till the function executes, that we have already discussed, and these memory locations are freed as soon as the function returns. So since the uh, values only, okay, the only things that mattered in such a case are the values, um, since the values traveled to the function, the called function, um, the memory allocated for and any variables in the calling function they remain unaffected by this whole process, right? So this is why we say that these are pass by value, because everything that is traveling is just values, right? Now in pass by reference, what we really do is that we actually, instead of sending values, we start sending something known as a reference. But just to understand, right, what is the advantage of passing parameters by value? Um, there are actually no side effects of calling a function. So what do we mean by side effects? Essentially, let us say I called a particular function from another function. So let us say in our sample scenario, I was calling g from f, and there was a value being passed from there are two values being passed from f to g. uh, whenever I say side effect, I essentially mean that there are no changes in any variables in the calling function, so in this case f, okay, irrespective of what happens with variables in g, right? So for instance, in this case I actually have two variables called a here. I mean, it could have been anything else as well. Instead of a, it could have been I, j, k, anything, but basically there are two variables here, and I was passing this variable to this function g. But whatever changes I make to the a here, okay, they are not reflected in the a here. So as soon as the function returns, because this is a different memory location altogether, as soon as the function returns, uh, the the value of this a, right, it is basically the same as just before the function call, right? So there is no effect on the value of this a. Now this is good, right? In most cases it is good, but in some cases we actually need these side effects, right? The most common example is when we are actually expecting a particular function to change more than one value for us, or basically when we expect that the function is going to return more than one output for us. We'll also have a look at one such example later. But basically the trick in order to do this is to pass one or more parameters to the function by reference. So reference is a generic concept. So essentially it means that there is some kind of indirect link between a value and a memory location. That is in the very crude fashion, that is what a reference is. So this usually involves sending the address of a variable as a parameter value from the calling function, okay, and in the called function we use a pointer to store this address. So something like this. And it's the same example. We have the function f and the function g, but here the first parameter, right, of function g, it has become a pointer. So I have used a pointer called p, and from here I'm basically passing the address of a. Instead of a, I'm passing ampersand a. So this is basically the address of a. Now in the in the called function, whatever changes we are going to make using this particular pointer variable, those changes are going to be at the same location where the variable in the calling function was residing. So this means that whatever changes I make in the called function, it will be visible in the calling function, right? So essentially, the actual value of this variable, it now loses significance. Okay, why? Because what I'm really doing is I'm passing the address of this variable a to pointer to this function g, and now whatever changes I make using this particular pointer, right? And how do I do that? I Instead of using a, for example, I'll use asterisk p. So whatever make changes I make to asterisk p, they are actually going to be made at this particular memory location, and hence whenever g returns, those changes are going to be visible in f. This is the overall idea, that in this way I can actually get more than one outputs from a function, right? So essentially I use parameters as a kind of they play dual roles here. They not only do they actually pass inputs to a function, they are also used to receive outputs from the function, right? Because the called function simply changes the values at their memory addresses in order to make these changes visible to the calling function. So this is an example of how call by value or pass by value is different from pass by reference. So this is a very simple case where we are trying to swap two variables. I have two variables a and b, let us say, and they have some values. I just want to swap these values, right? So whatever was in b, it should be a, and whatever was in a, it should be assigned to b. Now, uh, let you know, so essentially this example in the first iteration, this program is basically using a function that is called imperfect swap, right? Because this swap is not really what we want, okay? Because this function is supposed to send me two outputs, right? So if I'll give it two inputs, the values to a and b, and then the output I expect from it is another two values. It's just that the value of a should be returned as the value of b and vice versa. So I'm actually expecting this function to send me two outputs. Now what I'm doing here is, in the first attempt, I'm simply passing the parameters by value, the usual way that we have known till now. So what really happens is, yeah, even though the values are changed in the function, right? So you can see that earlier a was 5 and b was 15, and after the swap a became 15 and b became 5. If I actually go back to the main function from where it was called, you'll see that the values of a and b are unchanged, okay? They are not affected at all. When I use the better version of this program, the perfect swapping, right? This is the second attempt. We basically change things from pass by value to pass by reference, right? So essentially, now I'm using some pointers. This is these a and b are now pointers, and I'm using everywhere I wanted to use a, I'm using asterisk a, and wherever I wanted to use b, I'm using asterisk b. So you can now understand that they are basically going to the same locations where the a and b in main were allocated memory. So what happens is, now not only are the changes reflected in the called function, they are also reflected back in the calling function. So this is the overall idea of passing something by reference, that you are not really passing the value itself, you are basically passing a reference, a place in the memory where the variables are stored. There are some more points that you should note. This same concept, okay, passing by value, passing by reference, they can also be applied to returning values. So you can also, for example, choose to return an address instead of returning a value. The major thing that you should keep in mind when you are trying to return an address is that that address is actually accessible um, to the calling function, because uh, you all know that whenever you create a local variable, its scope is still the particular function in which it was created. It has not returned. So as soon as this function returns, the local variables in that particular function, they actually vanish from the memory. So if you return address to such a variable, that is going to be a problem. You'll probably get unexpected results. So but still, one good candidate to return the addresses for are any memory blocks which were allocated using the malloc function, right? The dynamic memory allocation function. There is one exception, we can probably say, to all that pass by value uh, talks that we had about C, um, and that is basically the case when you try to pass an array to another function, right? So the arrays are always passed by reference. And why is it so? Because this is because, by default, array names are actually pointers, right? They are not really uh, something else. They are basically pointer constants. So if you remember, if I'm writing an expression like arr, where arr is the name of an array, um, that is essentially equivalent to writing ampersand arr 0, right? The address of the first element of the array. So if I go back to that same trim function that we wrote in the previous week, here what I'm now trying to do is, I have actually stopped returning any value from trim. Why? Because I'm simply operating over the same array, the same string that was passed to me. And you can see that here, even though we are not really using the ampersand operator anywhere, we are not explicitly passing any addresses. What really gets passed from here to here is an address. And this is the whole idea, that if you actually want to see whether the changes are being reflected in the uh, calling function or not, you can try it out, and you see that the changes are being reflected. This is the idea, right? There's one more point that you should understand. This is especially for students who are either studying C++ right now or may have studied C++ in past. It might be a little confusing for you, because in C++ we have three different terminologies: pass by value, pass by reference, as well as pass by pointers. And whatever we have just seen is essentially taught as pass by pointers for C++ programmers. Um, so from that perspective, you can probably say that there is nothing like pass by reference in C. But there is a clash of terminology. So for example, people like me, we feel that and this is because there is really no concept of a reference in C language. Um, but so essentially what is happening in C is that you are emulating pass by reference using pointers. So this is the idea. And there is actually a nice link in the homework that I want you guys to read. So the idea is something like this: if you are treating the term reference in a generic sense, generic as in um, as a programming concept, then yes, you can call this as pass by reference, and you basically say that in C, pass by reference is implemented through pass by pointers. And if you are just talking about the term reference with respect to references in C++, then no, there are no pass by references in C. These are essentially pass by pointers. Okay. So just have a look at this link. We are going to discuss this lecture on Monday. Thank you. Bye.